Okay, let's start now. Let's put our first our script there. Let us load our data. Let us have our libraries. I think today we're going to have a few libraries. Today we have, let's load tidyverse package. The tidyverse. Have the one that I told you about. GGally. So where is our data? The physiochemical parameter data. Yeah, it is physiochemical. All right. So let's call it df. And we're going to change some of these things here as usual, as we do. The station, let's make them into factors. Station 1, station 2, station 3, station 4. There are 4 stations, I believe. And the months, you're also going to change them into factors from the month of May, June, July, August, September, finally October. Okay. So let's copy that and paste it here. Let us run it. All right. Now, let's have a look at this data. Now, looking at this data, I would like us to do some correlations. So a correlation, we want to know what is the correlation between transparency and depth, or transparency and temperature, temperature and depth, dissolved oxygen and temperature, conductivity, maybe in transparency. You'd like to know what is a correlation. And a correlation is just shows a correlation. The correlation shows how two factors are related to one another. Are they strongly related to one another, or are they not strongly related to one another? They might be strongly related to one another, or strongly unrelated, or they might be weakly. So here we have strong and weak correlations. Now, this GGally does very good for you. So what you have to just need to write here is ggcorr, and then it is your DF. Before we do that, I'd like to show you something. Last time I showed you how to filter so that to select some of the variables here. Now, I would like to show you another way of selecting variables. So let's say, for example, you want to select these rows, the first to the fifth row. First to the fifth row. So this is, use these parentheses. I don't know what the forms of brackets, blocks. So say you want from the first row to the fifth row, you put a comma. So anything that is before this comma represents the rows, and everything that comes after the comma becomes the columns. Now let's take from the first to also to the fifth column. Let's see what happens from first to the fifth. To the fifth column. So this is what you call subsetting. So the other part of using filters and select, it was subsetting, and also this is a way of subsetting also. So we have taken a subset of from the first column to the fifth, from the first row to the fifth row, and from the first column to the fifth column. So these brackets, these square brackets, what they do is that they're used for subsetting your data. So when you're using GG correlations, we want to subset our data because this the ggcorr only uses integers or numerical factors. Anything that is numerical, it is the only one which it uses. Now, from this, I would like to select only. I want to select all the rows. So selecting all the rows, I just leave it blank, then comma. And then this means I've selected all the rows. And then I want to select which column from there. This was the fifth column, from the fifth column to the 20th column. So column number 5, you want to subset from column number 5 because you only want things that are numerical to column number 20. Then let us run that. That's what happens. So this is a correlation matrix that this gives you, that function gives. It only deals with the numerical variables. So the only thing that we are lacking here is the value of the correlation. So to add the values, you just put a comma here. After that, you put a comma, and then you say label. You want to see, you have label is equals to true, capital T. Let's see how that happens. Now we have the correlation. Now you can take correlation between anything. The correlation between, let's take for example, between dissolved oxygen and temperature is a negative 0.2. So this is a negative correlation and not a very strong correlation, because correlation, correlation ranges from -1 to 1, from -1 to 1. So if 1 is a perfect correlation, it's 100%. So -0.2 is a weak correlation. So for example, if we take a correlation between dissolved oxygen and dissolved oxygen, it will always give you a correlation of 1. But let's check some of things. What happens when temperature increases? What happens when depth increases? What happens to the temperature? The temperature, here it says that the temperature reduces, obviously. Temperature has to reduce. This is temperature and dissolved oxygen. This is depth and the DO, they meet at 0.5. So they have a correlation. So as the depth increases, the dissolved oxygen increases. As the depth increases, temperature increases, but should decrease anyway. But that's the data that you're using someone's data. You don't know how accurate it was. So this is how you generate a correlation matrix. So what is the ratio between dissolved oxygen and some of these fish? Let's look someone like, let's look at this rotifers and dissolved oxygen, -0.5. So if you reduce the dissolved oxygen, these ones are negatively affected. So that is a correlation matrix, as simple as that. You can do something else called ggpairs. We want to do the same. Yeah, we want the numerical variables to 20. Okay, let's see what that happens. Let's see what that gives us. So it is compiling here. So in the first step, instead of doing a correlation of one after the other, you can do a correlation matrix for all of them, just as you can do a correlation matrix in Excel. You might have come across that. So The important thing today, this is the one way of subsetting. We have not yet come to data manipulation, but this is one way of subsetting your data. The first part I've said deals with the rows, and the second part deals with the columns. Now in this case, by not selecting anything, you're saying that you're selecting all the rows, and from the 5th column to the 20th column, to the last column. Now this ggpairs also gives us the, okay, let's see this. Now this one, let's make it, instead of having all the way, let's just have the physical chemical parameters from transparency, so to chlorophyll. So from 5, 6, 7, 8, 9, 10, 11, 12, 13. So up to 13. Let's take, instead of all those things that are not physical chemical parameters, let's take up to 13. Let's see what happens. This gives us a better visualization. These are these physical chemical parameters on their own. Can take the correlation of which. So also this one, let's take up to 13 as well. So it gives us something a little bit better. Only dealing with the physical chemical parameters. Yeah. Okay, here are other correlations. So the correlation between salinity and transparency also gives you there, and also the distribution of salinity, how the salinity distribution, pH, the distribution of how it is in form of a density plot, and this is a scatter plot. Now, something else we can do. This is not a very beautiful plot, so let's put the aesthetics and say color. Let's color them according to the station. Which station? And this station. Let me see how the station is written. Return station. Yep. So we have 4 station. Let's see the correlation between the different stations. Station. Okay. Station at found. Let's try with the month. Okay. Let me see. So okay, what you can do, let's in this case, let us not select any of the columns, let us select all the columns and then fill with the month. See what happens. So I would like to create another data set that has what I want. So I want all the rows, and I want the columns from, this is the fourth, from the fourth column, to the 13th column. Yeah, this is my df1. So let's see how my df1 looks like. Let's stop this, just doing something. So let's, instead of, let's take the data set that we have a subset of, and let us run that. So we are subsetting with the month, just to know the different, how the parameters differed across the months. That's why we are filling the month. That should be color, sorry. See what happens, however. Okay, let's come here. So this gives us the distribution for the different months. And because I said fill, that's what's having issues, but it is okay, it's okay. So it gives you the correlation of the salinity and the dissolved oxygen temperature and anything that you want, and gives you a sample of the distribution of that data. So let's, instead fill, we say, let's say color. Yeah. And we can have another DF2. Let's have another DF2. This time round, I want to select all the rows, and I want to select the first column. You have to put a C, put it into concatenation. So we need the first column, and then from the 5th column to the 13th column. So this gives us better. So it gives you the correlation for each of the month from May, for June, July, August, and September. So it gives you the correlations for each one of the months. They might not be clear, but it's okay. So give the correlation for the whole and the correlation for each one of the months. The correlation of transparency and temperature for the month of May, for the month of June, for the month of July, August, September, and October. So it gives you for each one of those parameters. So for, let's also DF2. Let's do ggcorr. So DF2 and label is equals to true. Okay, so that is, so let's have ggpairs. So DF2, and let's put aesthetics and color is equals to, the color is equals to the station. We'll choose the station. So let us run that, see what happens. So in this case, we want to do a correlation for each of the stations. Okay, let's see this. So this is according to the stations. Station 1, Station 2, Station 3, Station 4. So 0.641008, so it gives you correlation for each of the stations. So that's how you do a correlation matrix, where you want to know the correlation between any of your variables, any two of your variables, how they are correlated one with another. And you can check for each and every station, or you can check generally for all of the stations together. So let's see. So that's it. So that's the GGally package does for you. It provides a visualization for the for correlation of any of your data, also for the distribution of the data using ggcorr and ggpairs. These are the only two functions, ggcorr and ggpairs, found in that package called GGally. So that is it for today. That's all I wanted us to today. Just try practicing with it, and if you come up with any issues, we are going to solve it. Yep, that's it.
Hi, Dan.
Yes, yes.
So now I'm thinking, is there a specific value for the correlation, or you just look at it when it's negatively correlated or positively? Or there is a range, maybe say if it's a 5, I can know it's maybe me strongly correlated, or it's just weak and strong, depending on whatever parameter you're looking at.
Okay, so it just so the correlation matrix or correlation itself, it just shows you the relation, how the relation between two variables. So their relationship can be strongly related, positively or negatively or weakly. If there's a correlation of 1, that means there's a perfect correlation. They are related, they are parallel, they're one with another. As one increases, the other increases with the same magnitude. So let's say, for example, we have something like uh, depth and what? Let's take something that is so. If when depth increases, the dissolved oxygen also should increase. So let's say, for example, they were increasing perfectly. So if for every 1 unit increase in depth, temperature increases the same level. So maybe 1 degree increase in temperature, also one in depth increase in maybe 1 meter or a centimeter, whatever. So that is a strong correlation of 1. They can be negatively correlated. Maybe it's -1, a positive, a negative, strongly correlation. So when depth increases with 1 unit, maybe dissolved oxygen reduces with the same unit. So that is a very strong negative correlation, indirect correlation or negative correlation. You get the point? And the correlation
Yes.
can be weak, can be around maybe in the middle, maybe 0.2, something very little. So the correlation runs between -1 and 1. So that's where the correlation are. So any correlation that is 0.75 and above, either negative or positive, 7.5, 0.75, that is a strong, stands a strong correlation. Anything that is below maybe 0.25, that is a either positive or negative. 0.25 is a weak correlation. Are you
Weak.
getting the point?
Yes.
Yeah, so
I
that's
just wanted to know the limits.
no,
So now
the
I
limit
know
is just
negative
negative,
1 to
from
1.
-1 to 1. Yes. So that's how you do.